Okay, hello students. Here, this is Unit 2, Algebra 2, sorry, Unit 4. This is Lesson 5. So, what is Lesson 5? It's about changes over rational intervals. If you see at the bottom, the learning target for this is let's look at how an exponential function changes when the input changes by fractional amount. So, it's not like just like x increases by 1, 2, 3, it could be increases by 1/2, 1/3/4, and that's what that means. I can explain why an exponential function changes by a same factor over equal intervals. So we will see, investigate what does this mean, and straight away I'm going to go to the cumulative practice problem here. So I'm going to go to the practice problem. So as I said, so I'm making these videos to help all students. Uh, be, so the tasks of the lesson could be done in the class or using the Desmos activities 5.1, 5.2, 5.3, and then including the cool down. But here I would like to do only the practice problem because we don't get enough time in the classroom, and that's why I'm making these videos. Okay, so as I watch this, make sure you, after watching, you subscribe this YouTube channel of mine where I make videos so that you can have more access to more videos coming up. And not just algebra too, it could be also pre-calculus, and I have a lot of calculus videos also. So when you go to university, it will always help you. So let me go directly to the practice problem, and here it is. Uh, wait a minute. So the first question is asked. Wait, let me go here. Practice. Here it is. I have to click on this. So this is so you have a table. The first problem of the day is mm, uh, this part is coming in my way. Okay. So let me. So before I show you the first one, let me walk through some of the basic necessities. Remember that if I have a square root of b, it is square root of b, and I'm writing it. It means it is b raised to half. So this means and this means is the same thing. And you can see b raised to half, and if I multiply again b raised to half, you get b, right? So that means 2 of this, b raised to half, 2 of this, you get b. And that means this 2 crosses and b is b. So these two when you multiply, you get this. So one of them, that is b over 2, is square root of b. So that's all. That's the reason. Second thing you also should know is, is if you have cube root of b, this means it is b raised to 1/3. Because b raised to 1/3, if you multiply 3 times, you get b raised to 1/3 plus 1/3 plus 1/3, which is b, right? So that's why we say if b cube is, if, let me go, it means if I, what is the meaning of, if I have cube root of b is some x, then b is x cubed. So that's what. So the goal is just to make sure we know this part. And one more thing is, let's see. I'm making a table with, let's see, x and f of x. So 0, 1, 2, 3, 4, and 5, and 6, and 7, and 8, and 9. Let's say, okay. And in the beginning, the first output is 1, and I multiply with the growth factor as 2. And 1 times 2 is 2, 2 times 2 is 4, 4 times 2 is 8, 16, 30, and you see doubles. Clearly, you can see what I'm doing. So the main reason I'm showing is why I'm showing this 256 and 512. Okay. Now, equal intervals means, let's see. So if I go once like this, then the factor is 2, right? And every time it is 2, 2, 2, 2, 2. So if you go 1, 1, 1, 1, the factor is 2, 2, 2. Now, why I'm showing is if it is, let's say 2, from here to here jump, you'll see you have to go jump twice. So you multiply into twice. So from here to here, the factor is It will be 2 times 2 is 4. See, that means from here to here is the 4. And same if I jump one more from here to here, then again this is 4. See, so equal intervals, this equal intervals, and this interval. So this interval 2 increase into x increases by 2 here and there. So the factor is the same for this. See, even if I want to go from 4 to 6, you will see you have to multiply 4 here. 4 times 64 is like, because you're multiplying 2 times, right? And the same thing. But you can also think of something more, 3. Let's take increase of 3 then. If um, I use from here to here, see, now it is increased by 3 and it goes from here to here. So the factor is 8. How did you get 2, 2 and 2? So from here to here is the growth factor is 8. And again, if you go increase of x increases by 3, then again it increases by 8. So the factor, the growth factor remains same for the increase in the output, or the difference in the output. If it is the same equal intervals, so this is 3, this is 3. So for this one and for this one, it is the same. That's what you're supposed to do. So the goal here, the next one is what in between. I'm just keeping some. See, this time I'm doing like 0 was 1, right? Let's see, sorry, 0 was 1. Let me do one more time. So 0 was 1, okay, and then 1, when it is 1, this one was 2, because 1 times 2 is 2, right? And then again, if it was 2, then 2 times 2 is 4. So what about in between? If there are more, let's say I can split this into 4 more parts, and you can clearly see this is 0, let's say this is 0, this is 0, this is, so this interval from here to here is 1/4, this one is 1/2, this one is 3/4, and this is 1. See? Okay, so this is 1. So that means now from here to here is 2, right? So this is 2. So you're multiplying 2. So the growth factor, that B I'm talking about, is B. The question is, what is the growth factor? Suppose here, this part, say from here to here, this part. So so what is that B should be here? Like if this is B is 2, so what is that? And I can call, let's call it this as capital B. This B is the growth factor when it is from 0 to 1, right? Now I want to use this one. How much is B? Let me use this. So what is that B? So you can see multiply from here to here, from here to here, from here to here. So from here to here and from here to. So that means in order to reach 1, from here 1, 2, let me clean this. The slight mistake I'm doing, and that is, let's see, I'm making this again because I messed up there. So here you have 1 here, right? So and I want to split this into, so this is 0, then I want to get 1/4, then I want to get half, okay, and then I have 3/4, and then it is 1, see, from here to here. So we want to know what is that B, see, what green, this green, black color B, that's it. So 1, then 2, then 3, and then 4. So how many B raised to 4? It should be equal to the big B, uppercase B, and you can clearly see that lowercase b is B raised to 4th root of B, which is B raised to 1/4. That means whatever is this 2, which was 2 in this example, one of them, that is the quarter of that one, that B is going to be, that B is going to be, the original is B and 1/4. See, so that's how it changes. Because B raised to 1/4 times B raised to 1/4 times B raised to 1 over 4 times b raised to 1 over 4 is b. See, because from this was, this is the b which you see here. This one is uppercase b, but this lowercase this part. So every time for equal intervals, let's see. So this also will be same. This also will be same. This also will be same. But if you want to have only, let's see, uh, so if I clean this off, okay, this is the main one, and this is the main one. So what about from here to here? This part, see, we know we know from here to here is b, the uppercase b is 2, but if I take two intervals here like this and then again this 2, see, so what is that part will be? Because there are two, so in the main growth factor from 0 to this is 2, so each one of them will be 2 raised to like this one, and again 2 raised to. So this is a little confused. That's why the lesson is about fractional powers. This is part. So equal intervals, like from here to here, two parts. These are two intervals, and from here to another two intervals. This remains the same. So it's 2 raised to 1 half and 2 raised to 1 half. Let's go dive down straight away to the problems. So you can pause this video for a while and read the question. Okay. So this table shows you, this is the table shows uh, the store, the monthly revenue of business rises exponentially. So they did tell us that it rises exponentially, and maybe in the beginning it is something like, so this you're given this is like 72,000 is the revenue when the store was open, and then it goes 1, 2, 3, 4, 5, and so on. Okay, so that's like given to exponentially. That means there is some percentage increase every time. So some information is given, so you are given 1 here, then it rises to 3, and then it goes to 4, and this goes to 6. So the first question they ask in describe how monthly revenue is growing. So how do we know how the monthly revenue is growing? So they did give us this is 0. In the beginning it was 0 here. So from 0, so you are given one of these answers is given, and they gave you a 3. So from here to here, so there are 3 months from 0 when the store was open. Then after 3 months, that's where you have 3 months passed, and you're given this also. So how do you know what is this growth factor? So I'll use this as the uppercase B growth factor. And how do we do is, so we don't want to know what multiplies to 72,000, so to get 90,000. So remember, if I ask you, if I have a number, let's see, if I have a number 2, and what multiplies to 2 gives you 6, uh, is, we know the answer is 3, but just imagine we don't know the answer, then what is another strategy that you can use is, we say, okay, you just divide by 2, which is 3, right? So that's what we are going to do here in this case and find out the growth factor. For 3 months, the growth factor will be 90,000. So I want you to copy this in your paper so that you really understand 70,000. So because there are 3 zeros, we can just cross this out. You can use the calculator if you want, but I think I can use this manually. 9 times 10 is 90, 9 times 8, and you can still reduce this to this, and you get 1.25. So that's the growth factor. So the first question, describe how monthly revenue is growing. So we can write the answer here is saying the revenue grows by, so revenue grows by a factor of, so we can write a factor of 1.25 every 3 months. Okay? So every 3 months. So if this is every 3 months, and then again we can check here also. What about from 3 to 6? And you can do same thing on B. Of course, you have to check, right? So you do 11, 1, 2, 5, 0, 0 divide by 90,000, and you can use the calculator. Of course, you are supposed to use the calculator. And I also want you to know 1.4. What is that 1.25 means? So I took the growth vector is 1.25, which is 1 plus 0.25. So what is that means is the we can write in the percentage, right? So this means the original whole. So this one means 100%, whatever the original, and the other one is 25 divided by 100. That is 100% plus 25%. So every three months, it is growing by percentage 25%. Grows by 25. But our goal is to find next question. Write the equation to represent the revenue as a function of month since the online store is open. So we need to write down. If you see this, there is a one here. You're given a one. I'll put a one here. They didn't give us two, so let me clean this up. So the second question, from here to here, sorry, from here to here, 3 months. There's an average jump of 3 months. The scale factor, see, is, I'll call it as B, which is 1.25, right? And from here to here is again B is 1 point. My goal is, how do I model this into a exponential function in months? So this is the part, not 3 months, but I want to have every month, let's say. So so this was for every 3 months. So the question is, you want to know every monthly revenue is growing, right? Describe how monthly revenue is growing. So this is for every 3 months, but we want to know every month, let's say. So if it is every month, so there's a one here. So from here to here is what? Now, to go from to go until three, you have to go from, what is the increase? 0 to 1. Then 1 to 2 is missing there. So I'll put a 2. And then 2 to 3. So there is a 3. So there's going to be a B. So we want to know what is that B, which multiplies 3 times to get 1.25. So this growth factor now will be 1.25 raised to 1/3. Remember, when you convert this into other side, of course, it is B equals cube root of 1.25, which is the same as, so this is what we are going to use. This is the growth factor. So that's the growth factor for each month. So if I want to answer this, here I'll put an arrow to show this part. So if you want to know what is this one, so you have to multiply it. So the growth factor here is B, it is 1.25 raised to 1 over 3. This part. So if I want to write an answer for this, the revenue, so the revenue is R and depends on the month. So the input is the month because this is the input. That's the output. So the input is M, so we can call this as M, and the revenue is this one. So if I want to know that, by formula, we see the chart on the anchor chart, it is also B raised to, this is, I use the uppercase, right, for B raised to X. So what is X? So here, uh, if I want to write input, let's say the revenue X. So basically what I'm writing is, if this is X, that means this is X. That means X stands for here it is, every 3 months. But we want to change this to every month. So when you write this, the beginning, this is the beginning, what was the profit was? 72,000. So it is 72,000. And then the B that we got was 1.25. Remember, it was 1.25. And because you want it every month, which is here, this is the growth factor every month. So we use X. Instead of x, we use m month. So it is m month divided by 3. So the question is, if some of you may get confused, what is this? Like, look at this. This Rm is 72,000 multiplied by the actual. Remember the b which I wrote earlier was 1.25 raised to 1/3. It's the same thing. So that was the every month, right? So I need to write that 1.25 right here raised to 1 by 3 and then another bracket like this to put every month. So that changes to, see, that changes the monthly revenue is 72,000, 1.25, and this 3 will go below this. This m multiplies 1 and you get m by 3. So that's all it is and you're done. So this is the main kind of what is that called? Understanding the concept as how does the growth rate change. Now, if you want to really know what is the growth rate, this one we can put on the calculator 1.25 raised to 1/3 and put on the calculator maybe. And you can see, you can go in the Desmos here and just kind of put this. Made a mistake here. I think I'm something blocking here. Let me first take this off. So you can click on the keyboard in the desmos.com and just write down 1.25, 1.25, then click on raise to the power of b. So you go upish there and then you write 1/3. So 1 divided by 3, and you get the answer as 1.25 divided by 1. You get that's the 1.07. So that's the factor 1.0772. I'm gonna go back 1.772. Let's go back here. So this is going to be yeah, here it is 1.0772. See, so this growth factor, if you see, this is the growth factor for every month, and you can always write it as, let me write here, I can write it as 1 plus 0.0772, and that can be written as 7.72%. See, so every month is 7.72%. And if you want to do every 3 months, that was 25%. If you remember that, that part you can write, we've seen that. So if you see the next question here, find the monthly revenue 1 month. Okay, they're asking you what is the revenue. So what you have to do is, you already have, so this is the formula which is put in the box, right? So you put 1 here. So let me take up this MM and put a 1 there. And on the calculator, so I'll put 1 month, and you put 1 month, and this you put on the calculator, and you will be getting, can check that out on your calculator. So you end up getting 77. This one you put on the calculator, 77.559.65. So that will be the revenue after 1 month. So this number will go in the table right here. Okay. So if I clean this off, okay, and I put 1 month is, so if this is 1 month, this is 7, 7, 5, 5, 9, 6.65. Okay, now the next question they're asking is, what do you think, let's say, is, well, the last question is asking you, explain how we can use R1. So how do you use this R1 to find R4? That's what I'm trying to say. So we did know what is R1, right? So this is R1. How can we use that to this one? Now remember from 1 to 4, there's a jump of 3, increase in the 3 months, right? So that means what you're multiplying here is the every 3 months the factor. Remember the factor B was 1.25. So you're going to multiply here directly 1.25 because this is 3. So you just have to multiply 1.25 and get the answer. So let's go to the next. The second question is at 7 a.m. colony of 100 bacteria. So read this question. So there is a bacteria dish is something like this, let's say. And here there is a bacteria inside. In the beginning, it says at 7 a.m. is 100. So let me draw this to understand this better. Let me make a this way. Mm, yeah, I'll do like this. Okay. So that means, so this means hours passed. Let's see, this means hours passed from 7. So in the beginning, so if it is 7 a.m., that's like 0. If it is 8, 9, 10, 11, 12, 13. So so it's like 1, 2, 3, 4, 5, and 6. Every 6 hours. Okay. So this is 8 a.m. This is 9 a.m. This is 10 a.m. This is 11 a.m. This is 12 noon, and that is 1 p.m. So that is like 6 hours from 7 a.m. And the population of bacteria. This is you can write this as population. So this is population. So in the beginning there was population of 100. So this is 100. Now, but this 100 jumps to uh, it triples every. See, this word is very important. What is it? Triples means the growth rate. I'll write B uppercase as 3. So from here you multiply by B is 3. That is B. Now what does that mean is every 6 means in between you have 7, 8, 9, 10, 11, and 12. So this is 12 because this is 7, 8, 9, 10, 11, and 12. So this 100 which is in the beginning triple 3 times. If I multiply 3, you get 300. And then again multiply by one more 3, you get 900. See? So if it is 900 means that every 6 months, this is a group of 6 hours. The previous problem was about group of 3 months. The B upper growth rate was, I think it was 1.25, but here it is the same kind of problem. So the question is, before even we check this, by just looking at it, is one is what about every hour? How much is that? So the goal is to figure out what is every hour. So we want to know from here. I'm using the pink color. So from here, what is that? What multiplies? I'm using the solid and the small v. So what did we multiply? B here. So that means if you see from in order to go all the way from 0 to you start from 0 and you go all the way go from to 6. So this is 6, right? So that means to get this b, how many small pink b's do we have multiply? So this is one pink b, two pink b, three pink b, four pink b, five pink b, and six pink b. That means each one will be whatever is b, which is 3, that is 3, but raised to 1 over 6 because you have to multiply. Because when you multiply this 3 raised to 1 6, so it means 3 raised to 1 6. You write how many times like this? You go on multiplying how many times? 6 times. What you get is 3 1 6. So it is raised to 6, which is 3 raised to 6 over 6. And you really get that 3, the b, the uppercase b. So let me wipe this. I just thought of showing this because why is every hour what is the growth rate of when the bacteria is increasing? So that's what it. So B is this. B is, let's write that again. B is 1 160. B is 3 raised to 160. That's the factor. Now let's go straight away to what the questions are asked. Which statements are true when the bacteria is reaches 900? So that's like 900. So here I have 900. 12 hours have passed, and you can see really 12 hours have passed. So that's the first correct. 3 hours after the colony, yeah, 3 hours after the colony is placed in the pattern, there are 200. But you will see, uh, if it is here, this one, so he's saying if it is 3, it's going to be 200. So the right way to check whether this is 3 hours basically means in the beginning you had 100, right? So this is 100. So if they're asking you 3 hours, so that means every hour this is the scale factor, right? So we'll have to write 3 raised to, uh, so because 3 hours means this is 1/6 for 1 hour, right? So I'll have to do 3/6, and you can see that is like 100 multiplied by 3 raised to half, which is the square root of 3. It cannot be 200 because there's going to be a square root of 3 here. Look at this. So that cannot be the answer. So I wanted to write this to just get an idea how to go about. What about 3 hours? Oh, here it give you 3 hours. Oh, here you can use the calculator, and so this is 173. And the question is this really true? So I'm going to put this C here. So in the beginning you had, let's see, bacteria B, and H is the hours. So this, or we'll put population just to avoid the confusion with the other uppercase BR that I use. So population in terms of hours will be, in the beginning we had 100, and then the growth rate for every 1 hour is 3 raised to 1/6, right? And then instead of writing raised to the power h, I can very well write this as h. We can write just right here and put it here h. See, so h. And the question is asked after 3 hours, so you have to put p of 3, and you get 100 times 3 raised to 3/6, and 3/6 will give you 100 multiplied by 3 raised to 1/2. Of course, it is same as 100 raised to 3 raised to, or square root of 3. And remember, we do know from middle school, this is 1.73. You can check. You can use calculator. If you multiply, you get 173, and looks like this is correct. Now, what about D? So, I hope I'm making sense, you guys. In the first hour, the colony is placed, the population grows by a scale factor of, yeah, that's correct, 3 raised to 1/6. And I showed you how it is. See, here it is 3 raised to, even though I did not write it neatly, it is 3 raised to 1, that one. See, it is also uh, 6 root of 3. Then we get finally between 8 a.m. Now, what is how many hours is between 8 a.m.? It's like 1 hour, right? The population grows by a factor. We have seen the population grows by, so what they give is the, we know the answer is 3 raised to, every hour it is, now this is not same as this. They give you 3 raised to 2/3. No. So this is like, this is kind of 2 hours past kind of thing of, if I multiply 2 up and down, it's like, really, I don't want to understand. It's like 4 hours after the. So what they give is like 4 divided by 6. So 4 hours passed kind of thing after 4 hours. Hope that question. Even these two questions are, we are solving. It took time, but still, if you understand these two, the rest all are the same. Okay, look this problem. Look at that. There is a graph. Visuals are given. The graph represents the cost of medical treatment as a function of time. Okay, D. in decades. So D is decades. So the x-axis here is given as the time. So in groups of 10 days, group of 10 days. So because one decade is 10, sorry, 10 years. I'm so making a mistake. 10 years. Okay. Now, watch this. So the first question is asked is find the cost of the treatment when D is equal to 1. Means if in the first decade, how much is the so the one that they give it is at this point. So there's a slide. This is 0.5, comma 1202. This should have been like this. So there's a confusion here. So let's see if I can fix that. There's no, yeah, white. I'm gonna put this, and I'm gonna take this off. See, this part I wrote up there. So they give you in half when it is half a decade. That's what they said. So half a decade from. So this is half here. So this is a half decade from here to here. And what is half decade? There are 5 years, 2, 3, 4 years. See? And then this is 1. So we want to know what is this. So if it is 1, what is the answer? That's the question. Now in 1, from here to here, let's find a factor first because every interval, if it is exponential function, then every interval, so if this is half and this also will be whatever that means, whatever the factor. So we need to know what is this factor here. So let's see, what is that B? And I'll call it uppercase B, okay? So what is this B? Now to know this, what multiplies to get, what multiplies 150? So we need to know what is that 150, what multiply to get 202.50. So in other words, you just have to divide this on the other side. See, so it's like you can write what is that? So that B, uppercase B I use because at the lowercase b I always use for an interval increase in 1 unit. So that's that growth rate I use increase in 1. But here there is a half here. So this is half, right? This is 1, right? This is 1.5, and this is 2. Okay, so this b is half. So what is that? Will be 202.50 divided by 150, and use the calculator, and you will be end up getting if you do this, you get 1.35. So this will be 1.35. It's like 35% there. You can see that this itself means 35% increase for every 5 years, like a half a decade. So my question is, if this is 1.35, because they asked me 1 decade, D is 1, that means the other one will be also, this will be also 1.35. So it's 1.35. So basically, of course, they didn't ask us to write to model the function. We can also model this function if I want to know, like a decade, let's say, uh, cost, let's say C in decades, and we can write in the beginning we had 150, and the growth factor every decade. The growth factor for that will be use the other color. Even though they didn't ask us, means pink color I'm using from here to here. So you can see there are two small ones, 1.35, 1.35. So this basically means 1.35 square. So this is like square. Square means you put 2D here. So we can do that. So if it is 3 raised to 1, so you put 3 raised to 1, it's like 150 times 1.35 raised to 2, and you work this out and you get the answer as 273.40. So this is one way of doing in terms of decades, every decades. So there is no divide, there is a 2 here, so the factor is 2, or you can also write this thing can be written as cost equals 150 times. You can write 1.35, 1.35. If you multiply that, you get this part. So I'm talking about only the pink color part. So this pink color part, that 1.35, 1.35, you multiply, you get 0.169 raised to decade. So this could be also the formula using, because uh, as I said, this is the pink color that I showed is the growth factor for every decade. So that's like 0.169. I hope that even though they didn't ask us anything here, what I'm going to do is, so basically they did not ask us everything, but this one here is, so this is half, right? So this is half. So from here to here, it was 1.35, and you can see, and then because this is half a decade, this also is half a decade. So what they are asking is, what do you think is here? Well, and this thing is already for half, right? So you can use this number to figure out this. In other words, like if it is like 0, okay, and I'll put 1, and I put 2. So they gave us, say, let me put those numbers. So 0, then I put one here. So I put 1 here. So this will be half. So they gave you half is 202.50, and here they gave you the beginning is 150. So from here to here, you saw the grade, it was 1.35, right? So because this is increased in half a decade, from here to here also is half a decade. So that means you're supposed to multiply from here to here by same growth factor 1.35, because this is 5 years, half a decade means 5. This also is 5 years. Okay? So we can write this is equals whatever this was number which was here, you just multiply 1.35. So you could also write the answer as 202.50 multiplied by 1.35, and still you should get that answer as 273.40. Hope. Yeah, as I said, I'm just writing. I'm explaining a lot here, even though they didn't give you too much. I just wanted to make you hands understand that this is was given for every half, and you can use that same thing for every one, right? So then you have to multiply these two, and then you can build up the formula. Okay, this question number 4 is explaining. This is given to you, right? So this basically means 1 times 3 raised to x, and you can clearly see this is the beginning in the beginning, and the b, the growth factor here is 3. See? Now, question: what factor does f increase when x increases by 1? So instead of x, you kind of think of x plus 1. So you replace x plus 1. So this becomes 3 raised to x plus 1. And you can write it as 3 raised to x times 3 raised to 1, which is 3 times 3 raised to x. So the factor is this. So that's the factor. But if this is 2, what's happening? You're changing 2, you're putting 2, you're putting 2 here. This will be 2, and 2 times 2 will be 9. So simple. And if it is, next one is half. So you put f of x plus half. So the goal is just to make sure everybody understand that this could be written as this way, and you can write it as 3 raised to half times 3 raised to x. So the growth factor is this one, 3 raised to half. So basically what that means is, I would like to show also with the help of a table, maybe even though they did not ask us 0. So if it is 0, in the beginning it is 1. So there's a 1 here. Then if it is 2, sorry, if it is 1, it is, 3. If it is 2, it is 3 times 3 is 9. If it is 3, it is 27. If it is 4, it is 81. And 313, 243. If it is 5. So our goal is to make understand the meaning of this part. What is the meaning of this? X increases by half. That means from here, the in between, let's say in this part, and there is a in between, there is a half. See? So from here to here is 3. So that means we need to have two parts here, 1 and 2. See? So what is that? That's the question. What is that? Twice you multiply. So so that's like b. Let's see if I don't know. I'll call it b. So b multiplied by so to get the 3. This is 3. This is 3. So what is that we should multiply? So I'll put a box there. So what two things when you multiply should will give you 3? Or if you don't know, we'll put it like b, which is b square equals 3, and then put a square root sign, and you can see b becomes square root of 3, which is 3 raised to half. So that's what that means is the growth factor that you see, even though this will become robotic, easy to like algebra, but I wanted to see the visuals here. This is x, this is f of x. So they gave you from 0 to 1, but in between we should know also how to write. So 2 of this make the 1. That's what that means. Hope that helps. Let's do the last one, I think. So this question is question number, I think it is 5, question number 5, but that is from, if you have missed lesson 1, so this is a lesson 1 problem, repetition of lesson 1, unit 4. So let's see, a piece of paper is given. So in the beginning, there is a paper, I'm making a table. So this is like 0, this is 93.5. So a piece of paper is given. How many times do we need to be folded into half? So that means that's like a decay factor. This is called decay factor. It's going to decrease the area. So the area goes on decreasing like this. How many times do we want? 1 fold, 2 fold, 3 fold, 4, 5. So this means number of folds, and that's the area, right? So when will be the area less than square inch? So the final answer somewhere down here, 8. We have to get less than. So what do you do? We have to model this, right? So half means the b is half. So the formula. So this is b is half. So every time becomes half. So area. Let's see. Number of folds is n. Let's see. I can write in the beginning a naught times b raised to n, because this now I'm using n is number of folds. I'll put n here. So in the beginning you have 93.5 times b is half. There you go, and half raised to n. So what you can do on the Desmos thing is you can go over here and just plug in. There you go. Just take this off, and you just go on putting you. So you're given 93.5, so just type in 93.5 and multiply by 0. So 0.5, or you can just, so if it is 1 half, so multiply by, if you divide by, so instead of half I'll put 0.5. Okay, you get 46. What about if I put raised to the power 2? What do you get? You get 20. So what about 3? So 3 fold. What about 4 fold? What about 5 fold? You can see still 2.9. What about 6 fold? And it produce 7, and you can see it become smaller than, and that's how. Well, you can even create a function also, like a equals, and you just put that 93.5 times 0.5 to the power. You can see clearly here, and there it is. This is number of folds. So in the beginning, and you can make the y the big number little. Starts from maybe 100. So you know here it is. That's where it starts. And then goes down. So you want to know below 1. So, yeah. So how many folds? So you can still make it bigger and bigger. Like, and this is 1 here. Can you see this? The 1, 2, 3, 4, 5. So you have to have, so the graph goes below after 7. Do you see this? So until here, until 6 fold, it is above 1 square inches up here. See this? But the moment it goes here, it is 0 point is less, 7 fold is down. Okay, I think with this I want to end up. I hope this was taken care. So what did we do? As I said, I'm building up all iron practice problem. Hope that helps. Hope many of you may be having difficulty in some of. So I'm ending this. So this is unit 4, algebra 2, illustrative mathematics. Okay, unit 2, and practice, cumulative practice problem. Okay, would appreciate you guys when you're watching from I'm gonna put it on my YouTube channel. Okay, when you go there, make sure you first log in. I hope you first log in with your Google. Go to YouTube, then if this is the YouTube, there will be three parts here where you click on it to log in. There's a login here, and use your Google Classroom to log in, and you can comment in my YouTube channel also. What is that you learned? Maybe would appreciate your comment and like also, and do share with your friend circle also. Thank you. And I will continuously do this with my lesson number 5. I did. Next time I'll do 6. So hope this helps some of you maybe. And of course, I'm just doing it what comes in my mind, and I'm speaking out without even trying to, make it perfect kind of thing, which I will do as I progress. Do a lot of this practice problem. Maybe I'll do nice, neat, and clean. Thank you for bearing with me. I just want to show you, like, let's see, I'm opening let's say this is a browser, and I want to log in you, and I just type in youtube.com, okay, and I want to use maybe here, see, this is the thing which you have to sign in, and I will sign in. Okay, I use this is my wife's Gmail account, and I'm just using that. And once you go there, of course, um, you can type in my name, it'll be like this. And you'll see this is what I am, this is where I'm posting my uh, videos of I am. If you click there, and this is the first one that I posted today, what you did, this was done yesterday, right? Remember, this was done, all this were done for practice problem for lesson 3 and 4 together, I think I did. So when you click on this, make sure that you can just kind of thing, subscribe also, and if you can like also, you can comment here. So the reason to comment means what is that you learned and that you have to join in here. You have to have an account. Thank you.